force and bending moment at a point P, distance x from A. Since the beam is symmetrical, is it this beam symmetrical? It means if I cut it through the middle,
Oh yeah.
is a reflection of the other side, is a mirror
Yeah.
image, yeah? Symmetrical, we need deal with only half of it. We therefore consider two separated or to separate range of values of x, such as one, we take it as a x bigger than 0, less than a 2, and x is bigger than 2, less than a
5.
5.
5. Well done.
Try accidentally get it right.
And then you reflect the other side yourself, yeah?
Okay.
Draw it in reflections.
Yeah, yeah.
Or either you can go right to the end, make it 5, 6 cuts. Trick.
So you just did the same thing over again.
You just get negatives of what you got positive for the widget.
Okay, what I'm gonna do, let's do for the half of the B. So I put A is equal when the x is bigger than 0, less than a 2, and I cut the B. This is my cut. Yes?
Mm-hmm.
I start from point A, and I would be a shearing force here, cut at the point P, there would be a moment here, there would be a distributed load as well. The distributed load would be 1,000 times what? X. Am I right?
Yeah.
And the distance I cut, how big is it?
X.
Always x would be the distance of the cut. And then, when I done that, so the first thing you do is a symmetrical do for half of the beam. And then you can draw the bending moment identical to other side. I show you how to do that. And then cut the beam. Draw the shear force and bending moment. Construct the equation of the bending moment as shear force via when you cut the beam for the required a distance which we are required. So in order to make an equation of the shear force, would it be a shear force goes up minus 1,000 x goes down equal by 0 for this equation. And the equation of the bending moment, m at the P, took it positive, plus 1,000 x multiplied at, what's the distance of the 1,000 x? How's it from here, from point P?
So I was writing x over 2.
You coached you, but never mind. Okay, so this times that, and I make it positive as well. There is no force there. No. First equations. Let's make the life in the nice way, which is S is equal 1,000x. And this one, m is equal by 5 minus 500x squared. Yes? Yes or no?
Yeah.
Two equations. I done for the these two. Then I do x bigger than 2, less than a 5. And how I'm gonna do that? Bigger than, start from A. That's gonna be a reaction here, which is a 5,000. And that's gonna be a point of cut S. P would be a moment here. Yes? That's a point P is a point of cut.
Yep.
And then shear force would it be as a sum? And it would be the distance of the cut, I call it the X. It would be one distributed load goes down, which is a 1,000 X again. And the rest is a cosmetic S goes up. This goes down. Another one goes up. And the equation would be equal by, S is equal by, is it 5,000 or 500?
5,000. And 1,000x.
Thank you. In the next one, moment minus 1,000 x, it should be plus or minus, I think plus, times fx divided by 2. Yes? And the other one is minus 5,000 multiply at the distance. What's the distance here? To there. This one goes to user.
X minus 2.
Minus?
Minus 2.
I'm proud of you, sir. And there is anything else there?
No.
Can you make this more representable?
So minus 5,000 or 500x, and then minus 5,000x minus something.
Am I right? And what does he look like? Become m equal by minus. Then put it in this side. Can I clear this bit?
No.
To
Okay, you finish it later.
sorry.
Okay. Can I clear this one?
Yeah.
So this equation is already done. I'm gonna put it in the really nice order for you. Okay, these two equations and then work on them. One of the equation is for this bit is S is equal by 1000x and M is equal by minus 5000x squared. These two equations of shear force and bending moment for this range. And for that range, would it be S is equal by 1000x plus 5000 shear force equation. The bending moment equation would be minus 500x squared plus 5000x plus 10,000, is it? Yes?
Yeah.
I should be minus here, I think. Yes? This goes that side minus, that goes that positive, come back at it. Don't write anything, just listen to me. In order to draw the bending moment and shear force, we do the same things in here. So this is gonna be your bending moment here, the shear force diagram. Yes? I call it the shear force in Newton, as the A goes up there. And in here, we do a bending. You happy? You okay with that, yeah? Yeah. Right. And this is a bending moment, which is in the Newton meter units. And now let's put the values. The maximum value which is we have is around, and also the distance, you know, this is going to be 2 meters. Here is going to be how many meters? 8 meters. Here is going to be 10 meters. Am I right? And in here going to be 5 meters. Yes? And this is a 0. 0. I'm going to do for half of the beam. It means I'm going to do it up to here. And then reflect it in the other side. Does it make sense to you?
Yeah.
I'm going to do it for up to here. Let's look at the loads, what loads we have basically. Amount of the loads we have, anybody? One of them is a 10,000 and it can goes up to there, let me see how many. We go 10,000, yeah? Is it 1,000? Start from 1,000, isn't it? Okay, so we get it like this. Best way, we said to start from 1,000. Let's go a bit higher. 1,000, 2,000, 3,000, you go up, yeah? And this is a minus 1,000. And you can go down. Am I right? Yes? And similarly, you can go this way as well. Yes? Which is 0, 1,000, 2,000, minus 1,000. Let's go bit down. Minus 1,000 here. 1,000. And 2,000 here. Yeah? Minus 2,000. Happy? Right. Look at the equation. and deal with it. When the x is equal between 0 and 2, in order to solve it, you have to put the values in there, okay? In order to solve that, I use a Greek, you put the equation. These two is belong to this length, yes? This range. So I can start with the equal. It means I can employ the values from beginning. So I say for shear force, if x is equal by 0, s is equal by 0. If x is equal by 2, s is equal by 2000. Yes?
Yep.
Let's go for the second moment. If x is equal by 0 for moment, m should be equal by 0. If x is equal by 2, m should be minus
Minus 2000.
2000.
Minus 5. Minus 502. Yes. Yeah, I've got minus 2000.
Does it make sense? I put the x is equal by 2, 2 to 2 4, 4 times this one, 500 become 2000. Yes?
Yep.
Let's do over here. For shear force. If x is equal by 2, s is equal by 2000.
500. 2500.
If x is equal by 5, s is equal by,
5500.
sorry,
5500.
if x is equal by 2, m is equal by,
So minus 2000 plus 55,000. Plus 3,000.
are you sure?
Minus 500x is minus 2,000.
Yeah,
Plus
so
5
2 to
pounds.
the power of the 2,
Plus 2,000 makes a positive 3.
4. 4 times this one, 2000. This with 2, 10,000.
10,000.
After that 10,000, we're cancelling each other. Become, how much was it? M?
And
I think you made a mistake, yeah?
so first value is equal to 2,000 plus 5,000 times 2, which is 10. So minus 2,000 plus.
And then 10,000, this is 10,000, isn't it?
I cancel that, doesn't it? Yeah.
Yeah.
Yeah, it's minus 2,000.
Minus 2000.
Be careful. If x is equal by 5, m is equal by, you guys got the calculator.
Yeah.
How much would it be? To 5. 5 times that, 2,500. No, 5 times that, 25.
2,500.
2,500.
Yeah,
2,500,
No,
2,500.
25. 25 times 500, which is going to minus. And another 5, 25,000. Minus the 10,000, what would it be?
2,500.
Become 2,500? Yes? Yes?
Yeah, 2,500
Positive or negative?
would be positive, would it?
I think it would be negative.
Negative. How come?
I don't know, you put it. It is a 2-second job. Look, become minus 500 times 25 plus 5,000 times 5 become 25,000. Yes, minus 10,000. And how much it is?
There's a 2 as well.
What did you get?
So,
I think 2,500, yes?
yeah, but I got 2,500.
It's Is it this one goes positive or negative? Did I do right? When they go other side. Should be negative, isn't it?
Yeah.
Right. So we become 2,500, yes?
Yeah. I've got 3,500.
So, right. Okay, 2,500. Now, you got all the values, and let's draw it, yes? Is it 2,500? I got it to 2,000. Can we go to the 2,500